Yesterday we talked about graphing what the notes called, or the book's called, simple rational functions. And I said it doesn't necessarily mean easy, is what the word simple there is going for, but that is just first powers of x. Today it says graphing general, so that means that we could have any powers of x showing up in these. At the beginning of your notes, there's this formula that is like totally overwhelming. I promise it's easier than all the symbols look. What this means is we're going to have a polynomial on the top. Polynomial means all different powers of x's. So like an x squared plus an x cubed plus an x to the fourth or something like that. And then the same type of thing on the bottom. Okay, so we've got all kinds of x stuff on the top, all kinds of x stuff on the bottom. That's all that big messy thing with all those a's and b's and x's and n's means. Okay, is we've got x stuff on top, we got x stuff on bottom. Okay, x-intercepts are the numbers that make the numerator equal to 0. A fraction is equal to 0 when the top is equal to 0. So to find our x-intercepts, we are going to set the top of this thing equal to 0. We'll do that part by hand. Vertical asymptotes are where the denominator equals 0. We talked about this yesterday. Dividing by 0 is a big no-no. So when we try to divide by 0, it creates a break in the graph, and that break is the vertical asymptote. So we're going to set the top equal to 0. Those are our x-intercepts, so the places that the graph will cross the x-axis. We're going to set the bottom equal to 0. Those are the places where we're going to get a break in our graph, okay, the numbers that can't exist. So we'll do those two things by hand. And one more, our horizontal asymptote. The horizontal asymptote is a 3-part rule. Okay? The degree is the highest power that is present. So it says if the degree of the numerator is higher than the degree of the denominator. So the biggest power of x. If the biggest power of x, it says the degree of the numerator is higher than the denominator. So if the biggest power of x is in the top, there's no horizontal asymptote. Okay? So just kind of to abbreviate that, top means none. Okay? So if the top has the winning power of x, there's no horizontal asymptote. If the degrees are the same, so it's an x squared on top, x squared on bottom, x cubed on top, x cubed on bottom. If the degrees are the same, then we're going to take the fraction of the coefficients, just like we did yesterday. Because yesterday the degrees were the same. It was x on the top and x on the bottom. Okay? So we'll take the fraction of the numbers in the front. So if they tie, we do the fraction. And if the degree of the denominator is the winner, so if the bottom wins, it's at y equals 0. Okay? It is possible to have both a horizontal and a vertical asymptote, like we saw in the problems yesterday. It's actually possible to have more than one vertical asymptote also. Okay? We can have multiples of those. We're only going to have one horizontal asymptote, but we can have multiple vertical asymptotes. We're going to find those 3 things by hand, and then instead of making XY charts to plot points, we're going to let the calculator do the graphing for us. Because when we get all of these asymptotes, the graph gets very sectioned, and finding exactly what happens in each of those sections, making an XY chart, would be a pretty tedious job. So we're going to let the calculator kind of fill in what happens between the asymptotes for us. But we're going to find our x-intercepts by hand. We're going to find our vertical and horizontal asymptotes by hand.
When there's multiple vertical asymptotes, is that a tangent graph or something like that?
Well, yeah, like a tangent has multiple vertical asymptotes, like they keep happening. On a tangent graph, they're at nice equal intervals each time. In a rational function, they could just be kind of wherever. Yep. So in this one, we're going to start by giving our asymptotes and x-intercepts. So the horizontal asymptote, that's where we look at our powers of x's. So does the top or the bottom have a bigger power of x here? The bottom. When the bottom has the biggest power of x, our horizontal asymptote is going to be at y equals 0. Okay, so we can plot that into our graph. Vertical asymptotes happen where the denominator equals 0. Vertical asymptotes, we do denominator equals 0. So we're going to say x squared plus 1 equals 0, which means x squared equals negative 1. And I take a square root, and what do I get? What's the square root of negative 1? It's imaginary, right? We can't take a square root of a negative number. It's imaginary. Imaginary we can't see on graphs, so we're going to say that there's none. There aren't any we can see. They're imaginary. Okay, so this graph is never going to cross our x-axis. Or sorry, never have a vertical asymptote. The x-intercepts are where the numerator equals 0. So we're going to set the top equal to 0. 4 equals 0? No, it doesn't. So that doesn't work either, and we have no x-intercepts. So vertical, we look at those powers of x. For this problem, the denominator was the winner, and so the rule says when the denominator wins, it's at y equals 0. Vertical asymptotes, we set the denominator equal to 0. We did that, and we got an imaginary. That means there's none. X-intercepts are where the top equals 0. So we set the top equal to 0, and it didn't work, so that means there's none. So after we find our horizontal and vertical and x-intercepts by hand, then we're going to go to our graphing calculator. So on the graphing calculator, we are going to go and go into our y equals. In your y equals, clear anything that you may have in there from before, and type in the given function. 4 divided by. Now this is very important. When you're typing in a rational function where there's more than one thing in the top or the bottom, you must put parentheses so the calculator divides by all of x squared plus 1. Okay, so we need to make sure we put parentheses around that denominator because there's more than one thing there. Otherwise, the calculator is only going to divide by the very first thing. We want it to divide by everything. Then press your zoom button and choose option 6. That's our standard window, and that's always going to be our starting point. Sometimes we might need to adjust that, but we're going to begin. I'm choosing a window of -10 to 10 for both x and y. So it just kind of creates it's typically going to be a good viewing window for us, and we'll look at a couple where we do actually need to adjust things a little bit. So then what we do is just sketch this onto your graph. So by hand, we had put on the asymptote. If we had any other asymptotes, we would have put those. If we had x-intercepts, we would have put those. But all we had was that one asymptote, and then just sketch this onto the rest of your picture. Okay? So we're just looking for the few things to find precisely, and then the rest of it, we just want a general sketch of what it looks like. Okay? Yes?
So like for our graphs on our homework, like we can just come and sketch them out like we did last time.
Yep, just a sketch of the curve is good.
Does it have to be exact? Like the same points?
The asymptotes need to be exact, but the curve itself we can just sketch. So for the next one, the things we're going to find by hand are first our horizontal asymptote. Horizontal asymptote was a 3-part rule. We look at the powers of x. If the power of x is the same in the top and the bottom, which is what we have happen here, we take the fractions of the numbers in front of those x's, or x squareds, or whatever they are. So our horizontal asymptote is at y equals 3 over 1, or just y equals 3. Okay. Horizontal asymptote is where we look at the powers of x and who wins. If the bottom wins, like we had in the last one, it's at y equals 0. If they tie, they're both x squareds, we're going to take the fraction of what's in front of them. So 3 over 1 is 3. Vertical asymptotes come from where the denominator equals 0. So I'm going to set x squared minus 4 equal to 0. That gives me x squared is 4 plus or minus 2. So we have 2 asymptotes on this one. Whenever you take a square root in an equation, you get a plus or minus. So we start to get kind of a tic-tac-toe going on here. So our verticals are at x equals positive and negative 2. X-intercepts are where the numerator equals 0. So I set the top equal to 0, 3x squared equals 0. Divide by 3, x squared equals 0. And so x equals 0 is the graph, the point on the graph where we cross the x-axis. So we cross the x-axis right at x is 0.
Wait, so for to find the x-intercept, you have to do the top part.
Yep. The bottom part equal to 0 gives us asymptotes. The top part equal to 0 gives us a point. Okay, so I know 1 point on this graph. That's all I know. Okay. So to find out what happens between all those asymptotes, we go to our calculator. So then on the calculator, I go into the y equals, clear the problem from the last one, and put parentheses around 3x squared, divide by parentheses around x squared minus 4, and graph.
Whoa, she got
Yours may look a little bit different than mine because some calculators try to draw in the asymptotes and some do not. So mine's kind of connecting in those pieces, which is giving those asymptotes there. Those like lines that are looking straight up and down, they don't actually exist. Those are our asymptotes. Okay? So really what we have is 3 disconnected pieces to this graph. We've got our horizontal asymptote here. We have the vertical asymptotes that we found by hand. And we have that x-intercept that we found by hand. And then we have 3 disconnected pieces. In the upper corners, we have kind of like hyperbola-looking things like we had yesterday. And then in that middle one at the bottom, we have kind of a parabola-looking thing. Okay? So we get those 3 disconnected pieces, and we would want to sketch those into our graph.
Can you go back to the window?
You don't need to go back to the window every time. You can just go straight to the graph.
I won't go to.
Right?
I just haven't run on it.
Next example, horizontal asymptotes. Horizontal asymptotes. We look at the exponents and where the biggest exponent is. The top wins in this one. The top has an x squared, the bottom just has an x. The rule if the top wins is that there is no horizontal asymptote. Okay. If the bottom wins, it's at y equals 0. If they tie, we take the fraction. If the top wins, there isn't one. Vertical asymptotes are where the denominator equals 0. So x plus 4 equals 0 is when x is negative 4. So we have a vertical asymptote at x is negative 4. X-intercepts are where our numerator equals 0. Got a quadratic, you've got some options in how to solve this thing. You could use your quadratic formula. You could factor it. That's my favorite. I suppose you could complete the square, but most people don't like that. So I would say you're probably going to stick to quadratic formula or factoring. When we factor, we're looking for what multiplies to make 3, 3 and 1, that adds to make negative 2, negative 3 and positive 1. The solutions are then the opposites of those values. So we get 2 x-intercepts this time at x is 3 and x is negative 1. So this is what we can know by hand. We have no horizontal asymptotes because the top power won. We have a vertical asymptote at -4 because that made us divide by 0. So that's going to make a break in the graph. And we can set the top equal to 0 to find out where this graph is going to cross our x-axis. To figure out what else this graph does, we go to our calculator. So we go into our y equals, clear from the last problem, parentheses around the top. X squared minus 2x minus 3. Divide by parentheses around the bottom, x plus 4. Graph, I can see my asymptote again there. You might not see that because some calculators don't show the asymptote, some do. But we can see that asymptote there. I can see the 2 places that it's meeting through those x-intercepts, so I kind of connect those on through. Something must happen on both sides of a vertical asymptote. Okay? The graph must exist on both sides of the vertical asymptote, and I only see something happening on one side. That means whatever's happening on the other side is happening outside of my window. It's happening, I just can't see it. So what we want to do is adjust what we're seeing. So I'm going to go to zoom, and I'm going to choose to zoom out. Choice 3 says zoom out. When you do it, it's not going to make any difference at first. Hit enter, and it'll make a difference. Now I can see there's another little swoop thing that was happening. It was just happening so low we couldn't see it before.
I still don't see it.
Okay. So you got to zoom out, and after you select zoom out, you have to hit enter for it to actually regraph. It won't regraph until you hit enter.
Mine still didn't do it.
Doesn't that look like little beep things? That happened to mine too. Yeah.
Wow. Oh, that's it.
Yeah.
Josh, good about that.
What?
Good about it. Think I-
This chair, first one Clay's, first one black.
Yeah, the whole thing.
It wasn't before.
No.
No. It was when they hit enter.
You needed to resume.
Yeah.
Oh, it's because you had your grid background.
Is there a way to put the asymptotes on? So it looks like
Now
they're.
it's because you're on resume. Yeah, you get your grid on zero.
Wait, so you put the parentheses on both of them?
Yep, parentheses are on the top and parentheses are on the bottom.
Do you do that for every copy?
Yes.
Today?
Oh.
You working on it?
I'm working on it.
I was probably not having
Yeah.
attention today because I had to ask for the read
Is there a way to put asymptotes on?
Time goes, but it's.
No.
No, it just does it with something.
It's just a setting that some things do it, some things don't.
Okay, now I got some funky answers. I don't understand.
All right.
What? Let's
You
hear
feel
it.
that way,
For the next one, we have 3 more examples. They're really just one more model of each of the types of things we've already seen. So horizontals, we look at our powers of x's. The power of x here wins in the bottom. The rule is when it wins in the bottom, our horizontal is at y equals 0. Vertical asymptotes happen where the denominator equals 0. So x squared plus 1 equals 0. X squared is -1, and that's a problem. So there's none. X-intercepts happen where the numerator equals 0. So that would just be x equals 0. It is okay for a graph to cross through a horizontal asymptote. A horizontal asymptote shapes the ends of the graph. It tells those arrows at the ends of the graph what they're supposed to be doing. But it is okay for it to actually cross through a horizontal asymptote. So all we know is one point about this graph, and we know that the ends are going to flatten out. But we don't know anything else. So we go to our calculator to see what it looks like. So in the calculator, y equals, clear, put parentheses around the top of it. It's not totally necessary in this one because it's just an x. You need it if there's more than just one thing. But as a general habit, it never hurts to do it. So put parentheses around the top and then put parentheses around the bottom. Now on the last problem, we zoomed out. So I want to reset that, and I'm going to go back to another zoom standard so I can get back to that normal window, because on the last one we zoomed out, and I always like to kind of start back at the same place. There's something happening there. It's kind of hard to see. So on the last one we zoomed out so we could see more. On this one I want to be able to see it better, so I'm going to zoom in. So I'm going to go to zoom, and choice 2 is zoom in. And again, you have to enter before it'll actually redo anything. So what's happening is it's kind of swooping through that middle point and then flattening at the ends along that asymptote. So always start with a zoom standard, and then if you adjust it, when you go to your next problem, adjust back. Okay. So for our next one, the powers on the top and the bottom tie. When the powers tie, we take the fraction of what's in front of them. So y equals 2 over 1 or just 2. Vertical, we set our denominator equal to 0. So x cubed equals 1. And when we take a cubed root, we do not need a plus or minus. So we just have 1. X-intercepts, we set the top equal to 0. 2x cubed equals 0 when x equals 0. So horizontal, we look at the powers of x. Vertical, set the bottom equal to 0. X-intercepts, set the top equal to 0. And then go to the calculator to fill in what happens between them. So on the calculator, put parentheses around the top. And put parentheses around the bottom. And in the last problem, I adjusted my zoom because we zoomed in, so I'm going to go back to a zoom standard again. You could always do that instead of pressing graph. You could just always press zoom standard. Otherwise, if you haven't adjusted, you could just press your graph button. So then I can see the two sections. This one's kind of like what it looks like yesterday. There is something a little bit different than yesterday. Yesterday they were nice, kind of smooth curves through there. This one takes like a little bump right there, but you might not actually be able to see that very well, and that's okay. We're just sketching in. So this one isn't quite a hyperbola like we saw yesterday. It has a little bump that happens in it.
So how do you find the vertical asymptotes?
The vertical asymptotes are where the denominator equals 0. One more. On this one, the power of the top wins. When the power of the top wins, there's no horizontal. Verticals, we set the bottom equal to 0. x-intercepts, we set the top equal to 0. I'm going to solve by factoring. This is x minus 4 and x plus 1. So they multiply to negative 4 and add to negative 3. Which means my answers are 4 and negative 1. And then, hold on just a second. When you graph it out in your calculator, you're going to see, it's kind of like this. Okay, so you just sketch that in. On your homework, the first group of questions asks you to just find x-intercepts and vertical asymptotes. I'm going to tell you, you also need to find horizontals. You don't need to graph them on the calculator and do a graph of them, but for the first 6 problems, 11 to 16, the directions only say x-intercepts and verticals. I'm going to tell you, you also need to do horizontals.